Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at configuring management settings and services on the ASA. We'll be discussing entering global configuration mode, configuring basic settings, configuring interfaces, configuring a static route, configuring remote access services, configuring ASA basic settings using the CLI, configuring network time protocol services, and finally configuring DHCP services. This episode is part of my series on network security for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. The default ASA user prompt of Cisco ASA, and then with the greater than sign. This is displayed when the ASA configuration is erased, the device is rebooted, and the user doesn't use the interactive setup wizard. To enter privilege exec mode, use the enable user exec command. So type in enable, just like we do in our router and switch iOSs. Go ahead and type enable. This brings you into privilege exec mode. Initially, an ASA does not have a password configured. Therefore, when prompted, leave the enable password prompt blank and press enter. The ASA date and time should be set either manually or by using a network time protocol. To set the date, use the clock set command here in privilege exec mode. Enter global configuration mode using the configure terminal privilege exec command. And once again, you can shorten it down to config T or conf T to get into your global configuration mode. An ASA must be configured with basic management settings. Here are the commands to accomplish this. First one here is setting the host name. This specifies the host name, so the keyword host name, then you put the name of the device. They can be up to 63 characters long. Now, a hostman must start and end with a letter or a digit and have as interior characters only letters, digits, and hyphens. What we have to do next is set up our domain. So we have domain-name, and then what is the name of our domain? This sets the default domain name. Then we go into setting our privilege exec password. So enable password. This sets that password to get into privilege exec mode. It sets the password as a case-sensitive string of 3 to 32 alphanumeric and special characters, not including the question mark or the space. Then you should set up a banner message of the day. So it's banner MOTD, and then you use message. This provides legal notification and configures the system to display a message of the day banner when connecting to your ASA. The next thing we do is set our keys using the key, config key, password encryption, and then new pass, old pass if required. This sets the passphrase between 8 and 128 characters long, and it's used to generate your encryption key. And the last thing we should do here is password encryption AES. This enables password encryption and encrypts all user passwords. To configure a banner with several lines, the banner MOTD must be entered multiple times. This is not similar to our router iOS and our switch iOS. In our router and switches, we had to do banner MOTD and then put a delimiting character at the beginning, at the end of the message. So that was a special character that only did not appear in your message, but it signified this is the start of your banner message of the day, this is the end, and you can enter in multiple lines. Here on the ASA, you have to enter banner MOTD multiple times. So you start off every line, banner MOTD, you put in your first line. Then after you hit enter, you go banner MOTD, you enter in your second line, and you do that until all of your lines are done. The privilege exec password is automatically encrypted using MD5. However, stronger encryption using AES should be enabled. To do so, a master passphrase must be configured and the AES encryption must be enabled. When we look at our password encryption in privilege exec mode, we can go ahead and enter in the command show password encryption. We can see that when we first start off, it's disabled and the master key is not hashed. Now, to change the master key passphrase, basically to set it the first time, use key config password encryption and then what you want that password to be. This is in global configuration mode. So we did our config T here. Then go ahead and type in key space config dash key space password dash encryption, and then the actual password here. Then once the password is set, here we use Cisco 123, you go ahead and tell it what encryption you want to use. We enter in password encryption AES, and that's where we set AES as our password encryption. If we exit out and we do the show password encryption again, we can see that password encryption is enabled. Here is the master key hash. That's what we set up here in this line. The ASA 5506X has 8 gigabit interfaces. Those are right here on our device. Those are the 8 ports that are lined up together. These are all gigabit, and they can be configured to carry traffic from different networks. The G0 or the G11 port, so this one right here, and once again it's G1/1. This interface is used by convention as the outside interface and is set to receive its IP address by default. And so this address, you connect up to your internet provider, to your WAN provider, and it's set up to receive its address by DHCP. The remaining interfaces, so 2 through 8, so gig 1/2 to gig 1/8, they can be assigned to inside networks or DMZs. In addition, a gigabit Ethernet port is dedicated to in-band management. It's designated as management 1. Over here, you can see that there is a separate port. This port right here, it's not part of the 8. This is our management port. It is a port you hook up to your network, to your LAN, but it's management only. You can't pass any network traffic through it. There are also, right here, RJ45s and USB console connections for out-of-band management. The IP address of an interface can be configured using several techniques. First one we have right here is manually. So to configure an IP address on an interface, we can manually do it. This is commonly used to assign an IP address and a mask to an interface. The command looks like what we normally see when we configure a router or switch, a router interface, or the SVI on a switch. Go ahead and say IP address, then what is the IP address, all 4 octets, and then we put the subnet mask with it. So IP address, then the actual address, and then the subnet mask. The second way is we can use DHCP. This is used when an interface is connecting to an upstream device providing DHCP services. This is the same command that we use on the router iOS. It's IP space address space DHCP. The interface will request an IP address configuration from an upstream device. You can also use IP address DHCP set route. The set route is the new part right here at the end. This is used to have the interface request and install a default route to the upstream device. And then the third way to configure an IP address on our interfaces is using PPPoE. The command for that is IP space address space PPoE. And this is an interface configuration mode that requests an IP address from the upstream device. Sounds similar to DHCP, but it is a different protocol. And along with that, we also have the IP address PPoE set route. And it's the same command, but it also requests and installs a default route to the upstream device. Each interface must have a security level between 0 and 100. 0, once again, is the lowest trustworthiness you have. 100 is the highest trustworthy you can have. The commands here are used to configure basic interface parameters. The first step you should do in configuring your interfaces is name it. Name IF. It's not name if. IF is short for interface. This is a carryover from Linux days. So name IF, and then the actual name of the interface. So it's right here, they have it as the option IF underscore name, but this is where you put the name of the device. Inside, outside, DMZ, accounting, whatever you want to name the basically purpose or where that interface is connecting to, what local area network. Then we go ahead and specify the security level. So it's security-level, and then you put a value in there. Once again, the range goes from 0 to 100, where 0 is the lowest trustworthiness, 100 is the highest trustworthiness. And then last part here is you activate the interface. Same command we use in our router iOS. We do a no shutdown on it. That activates the interface. I hope you're liking this episode on configuring management settings and services for the ASA. If you have time, please leave a comment and let me know what you think about configuring management settings. You can also visit my website at KevTechify.com for all of my details and how to get all these episodes in video and podcast form. Let's look at an example of a configuration. In the center, we have our ASA 5506 firewall. We're going to use three interfaces on that. G1/1, typically that goes to the outside. So here we have the wild, wild west of our internet. This internet host, it could be a salesman out on the road. It could be an exec using VPN to come in. It could be one of your trusted partners to connect into your services. But it's across the internet. We don't know who's out there. I mean, it could be a threat actor trying to get into your network. That's one zone. The second zone, which we're going to hook up here to our G1/2, is the inside of our network. This here has all of your PCs, all of your devices. We have all the services for accounting, HR, ordering, payroll, all that in there. We have our big servers for enterprise resource planning. This is the part of the network we are protecting an awful lot. And then the third one, we're going to hook up here to G1/3 is our DMZ. This is a server that people from the outside need to access and people from the inside need to access. So that's what the idea of the DMZ is servers that people from the outside need to get to and people from the inside to get to. Let's start looking at the configuration process for our ASA 5506X. First thing we have to do is go in and configure our interfaces. So we start here, global configuration mode. We go into our interface, G1/1. We talked about how that's connected to the outside, to the internet. So we're going to go ahead and name it outside. And notice it's going to say security level for outside. It's using the name right away, is set to 0 by default. So when it sees you call the interface outside, it automatically sets it to 0. Just to make sure, double sure, you can go ahead and set your security level to 0. Once again, 0 is the lowest trustworthiness. Then we set our IP address. So right here, we're going to go IP address. We give it an IP address of 209.165.200.225 with the appropriate subnet mask of /30. We make sure to activate our interface. We do a no shutdown. That's the basic configurations that happen on an interface. We go ahead and repeat it for interface G1/2. We call it inside. When the operating system sees we call it inside, we automatically set it to 100. But just to make sure, let's go ahead and just specify the level here. We set an IP address. Once again, notice this is a private IP address here, 192.168.1.1. This is non-routable. This is your local area network. Also, what typically happens here is when you're setting up your firewall, this will also be our default gateway. So this will be our default gateway, our exit on and off of our network. So each one of those interfaces, typically G1/2 to G1/8, those will be default gateways on different networks inside of your company. Once you set your IP address, do no shutdown. Let's go ahead and rinse and repeat this one more time for our interface G1/3. So we go into G1/3, we call it DMZ. We don't recognize it. The operating system doesn't recognize it. So it takes and it gives it the most secure possible. We give it the lowest trustworthiness. So by default, we go ahead and set it to 0 because we didn't recognize this as one of our keywords like inside. But we don't want it to be set to 0. We want it to be set to 50. So we go ahead and do security -level, set it to 50. Then we can go ahead and set the IP address for our DMZ. Notice this will be the default gateway for that LAN. And we activate our interface. And then we can exit out. So we went through 3 interfaces. Basic processes for each interface: you set the name, set the security level, set your IP address, and then you activate it with a no shutdown command. We can also set default static routes on our ASA. This command is very similar to what we set on the router iOS. From global configuration mode, we use the keyword route. We use route, and then we give it the name. So this is the name of our interface. So we called one of our interfaces outside, so that's what we'll put in here. This is the keyword, or sorry, the name of our interface. Then we do our 2 quad zeros. This is the network. We don't care what we compare it to, so all unknown traffic is going to be caught by this statement. And then this is the next hop IP address. So this is the next hop IP address. This is the IP address of your internet provider, your WAN provider, your upstream device. To confirm the route, we use the show route command. Now, once again, it's not show IP route like on the router iOS. It's just show route here. Doing the show route, we can see that our gateway of last resort is set to 209.165.200.226. That's what we have. That was our next hop IP address. And this is the 00 network. So anything that doesn't match any of our known connections, any of our known networks, we're going to push towards our next hop IP address. There is also in our routing statement a static line. We can tell it's static here by the S, and we have our quad zeros signifying any traffic that isn't caught by anything else. We are going to send it to our 209.165.200.226 address, which once again is our next hop IP address, and it'll go out the outside interface. So what interface is it connected to? Telnet or SSH is required to manage the 5506X remotely using the command line interface. Now, to enable the Telnet service, and these commands are slightly different than on the router iOS. To set up Telnet, we are in global configuration mode. Go ahead and say password is Cisco. Now, normally on the router iOS, you have to go in the line VTY0 space 4 or 0 space 15, and then you set your passwords. At this point in time, what we do is we set the password. So right now, password Cisco, this sets the login password, and it can be up to 80 characters in length, and this is for Telnet. Then we say Telnet, we put in the IP address, the subnet mask here, and then what interface. This identifies which inside host or network can telnet to the ASA. Once again, notice it's an inside host or network. You can't do this from the outside of your network. And use the clear config to remove the telnet connection. Use the clear configure telnet command. Then we can go ahead and set a timeout for our telnet. So it's telnet timeout 3. By default, the telnet session left idle for 5 minutes are closed by the ASA. The command alters the default exec timeout of 5 minutes. You can use the show run command to verify your settings. So we did a show run, and then we added telnet on the end, so it lists only lines that start with telnet here. And we can see we have telnet 192.168.1.3 quad 255s on the inside port, and then we set our timeout to 3. We verified our settings. Now, you can configure telnet to refer to the local database for authentication. To enable SSH, there are several commands you have to enter. And it's about the same process as you would have to do on the router iOS to set up SSH. The commands are a little bit different, and the order maybe just is a little bit different. First thing you have to do is create a local database entry. We do that once again by using the username command. So we go ahead, admin. So we create the user called admin, and then we set it up with the password of class. Then we can go ahead and say AAA authentication, SSH console, and then local. And this configures SSH to refer to the local database for authentication. The local keyword is case sensitive and is predefined server tag. So this local right here once again, is case sensitive, and it is predefined. So it has to be all capitals, capital L, capital O, capital C, capital A, capital L again. Then we can go ahead and generate our crypto key. The command here is crypto space key space generate RSA modulus. And then modulus you can put in there are 512, 768, 1024, or 2048. At minimum, you should do 1024. It's always good to use a bigger key. Makes it harder to guess and crack your code. I like to use the maximum here, which is once again 2048. Go through the process. It may give you a warning that you've already defined it. Do you really want to replace them? If you're doing this again, go ahead and just say yes to do that. Go ahead. It creates this key pair generation, and you have to wait there. And you only have to wait like 10 seconds or so to get to that. The next step identifies which inside host or network can SSH to the ASA interface. Multiple commands can be used in the configuration here. And the command looks like this: SSH and the IP address or network address, followed by its subnet mask, and then what interface are you allowing that access to. If the name is not specified, SSH is enabled on all interfaces except the outside interface. To clear these out, use the clear configuration SSH command to remove the SSH connections. If you have multiple devices to connect in using SSH into your ASA, you can specify this line multiple times. Here we have it 3 different times. Go ahead, make sure and set your version to version 2. Version 1 is considered very insecure nowadays. But by default, the ASA allows both SSH version 1 and SSH version 2. We want to basically disallow SSH version 1. So the command here, SSH version 2, sets it to version 2 only. Then we can go ahead and use the show SSH command, and we can verify our settings. You can see down here that we have the default time of 5 minutes set. Version 2 is allowed. Then we come in here. These are the algorithms, the encryption algorithms, the integrity algorithms that are used. And then at the bottom here, we can see these are the hosts that are allowed to SSH into our system. Network time protocol services can be enabled on an ASA to obtain the date and time from an NTP server. First thing you need to do from global configuration mode, so once again, we are in global configuration mode, is we need to enable authentication with an NTP server. So that command here is NTP space authenticate. Once again, this enables authentication with an NTP server. Next thing we have to do is specify an authorization key ID to be a trusted key, which is required for authentication with an NTP server. How we do that is NTP trusted dash key and then our actual key ID here. Then we should set our key to authorize with the NTP server. How we do that is NTP authentication dash key. We put our key ID, so these two should be identical. Then we specify our method and then the key itself. And here you can think of this as either the key, or a lot of people will refer to this as the password. Get into our device. And then finally, you identify your NTP server. We do NTP space server and then the actual IP address of your NTP server. To verify your NTP configuration and status, there's 2 commands we can use. One is the show NTP status. And then the other command here is show NTP associations. Those 2 commands will let you know that you are connected into an NTP server, that you're syncing with it, and it'll give you some more additional NTP information. An ASA can be configured to be a DHCP server to provide IP addresses and DHCP related information to hosts. To enable an ASA as a DHCP server and provide these DHCP services to hosts, there are several commands we have to do. First step we have to do is create our pool of addresses. And how we do that is the command, and once again, we're in global configuration mode. So the command is DHCP Dynamic Host Configuration Protocol. The D is standing for daemon, which is a service that runs in the background. So you want this as a continuously running service. Then the keyword address and the range of addresses. Now notice this is a range here. So here we're going from 10.0.0.1 to 10.0.1.255. We don't have to have a network address. Actually, you can't put a network address in there, so you have to have a range of addresses. So once you have that range here, we can go ahead and specify what interface, and we're going to say that it goes to the inside interface. Or you could say this goes to accounting or the shop floor. Whatever you want to set this up as, because you have eight interfaces, one to the outside, and then most likely you have 7 to the inside. Maybe one goes to the DMZ. Then you have 6 different networks you can set up inside. Each one of those could have a different pool of addresses associated with them based upon this interface name right here. The key thing to remember here is the address pool must be on the same subnet as the ASA interface. If we go back and recall, remember the inside interface had an address of 192.168.1.1, 192.168. Here we're trying to assign 10 dot addresses to it. So it's going to give us a warning, and that's what happened right here. It gave us a warning and says the pool range is limited to 256 addresses, so you can't span more than 250 addresses. And also the set range here, the 10 dot addresses ranges we tried to use, is not on the same subnet as the inside interface of 192.168. So what we did here, we did a couple things wrong here. Here we did more than 256 addresses, and also we did the wrong subnet. It gave us 2 warnings. Let's go ahead, we correct the statement. So we start off with DHCP addresses 192.168.1.10 to 1.250. Now this is on the same interface subnet as our inside interface, and we are less than 256 characters. Notice the range statement. It doesn't follow any networking or subnetting, variable length subnetting processes. You can just specify a range. It doesn't have to match any of that. So right here, we're going from .10 to .250. We're assigning to our pool. Then we can set up our DHCP lease time. So here we're doing an 1800. And what this does is it changes the lease length granted to the client, which is the amount of time in seconds that the client can use the allocated IP address before the lease expires. The lease length defaults to 3,600 seconds or 1 hour, but it can be a value from 0 up to a little over 1 million seconds. You can also specify the domain name that's assigned to the client using DHCP domain and then specifying the domain name. Once you have your DHCP pool set with its correct information, you can then enable the DHCP servers or the daemon on the interface, typically an inside interface of the ASA. To do that, the command here is DHCP enable, because we're enabling it on the interface, and then you put in your interface name. So this would be inside, outside, DMZ, accounting. Whatever you set up your interfaces at, this would be the name of one of them. So it would activate the pool you just set up. It would activate all of this information down here on this interface. It would start handing out those IP addresses. It was my pleasure to provide you with this wonderful episode on configuring management settings and services for the ASA. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on network security for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.